working with collections of objects in the pipeline. In this nugget, we're going to talk about two different ways to work with objects. First of all, we'll start by examining what object collections really are. Then we'll look at some ways that we can work with entire groups of objects all at once, and some examples where we want to get a group of objects, but we want to work with them one at a time. Now, there's a couple of examples we're going to use for this. One of them is the use of the for-each-object commandlet and Windows management instrumentation. So we'll actually create a couple of useful little one-line commands that perform a couple of useful administrative tasks using object collections. So what is a collection of objects, or an object collection? Well, believe it or not, you've been seeing them all the time. When I run something like get service, that's a collection of objects. Really, collection is just a fancy word for saying a group of something. If we've got more than one service object, then that whole group together is simply referred to as a collection. PowerShell can work with these objects in a couple different ways. It can apply an action to the entire group at once, to the entire collection, or sometimes we may want to apply an action to individual objects within the collection one at a time. We've seen a few examples already of how to apply an action to the entire collection. For example, taking something like get service and piping them all to stop service. This gets a collection of service objects and stops the individual services. Now, obviously, it has to go in and stop each individual service one at a time, but the stop service commandlet is capable of doing it for the entire collection of objects produced by get service. When you start working with remote computers, you're going to want to more frequently connect to one, do something, connect to another, do something, connect to another, maybe do a whole sequence of things, and so forth. So PowerShell really gives us the flexibility to work with those things in two different ways. So let's take a look at some of those different ways and some of the different things that we can actually do within the shell. For example, if we were to run get service, that produces a collection of objects. We can run get service, just keep those where the status property is equal to stopped. Still a collection of services, a smaller collection, but it's still a collection of objects. And now let's pipe those to start service and actually ask what if. So start service was able to take the entire collection that came out of where object and attempt to take some action with them. It tried to run start service on each one of them. It's still actually trying to start each service one at a time, and you can see that by the what if output. But the start service commandlet itself is taking this entire collection. That's really common for local management. We do it a lot for things like files. For example, if I were to type dir star.mp3-recurs and then pipe those to del, it would go search my hard drive for all the MP3 files and then delete them all. Now, maybe I don't want to do that, but you can see that there are different ways that we can work with bunches of objects or collections of objects sort of all at once. It doesn't always work though. Sometimes you need to be able to work with the collections individually. Suppose, for example, that I want to reboot an entire list of computers. I know that Windows Management Instrumentation gives me that capability, but I need to kind of take it in steps. So I'm going to start by changing to the demo folder where I have a list of computer names in a text file called computers.txt. You can see that there's a number of different computer names there. So here's how this has to work. When I run the type command, remember that's actually the get content commandlet that's running under the hood there. Type is just an alias. That's going to produce multiple objects, a collection of objects. Each object is a string object, and it's the name of a computer. I need to take those names, let's just call them name1, name2, and name3, and for each one of these names, I need to connect to WMI. And I need to retrieve a class called Win32 operating system. But I need to go to each computer individually to get that class. I can't just connect to all three of them simultaneously in parallel or anything like that. I need to do them one at a time. This will get me WMI-A, WMI-B, and WMI-C. each WMI object I get back, I need to execute a method of that WMI object, which will actually reboot the remote computer. So I'm capable of actually getting multiple WMI objects back from each computer. So this creates sort of a hierarchy. GetContent, or its alias GC, is going to produce 1, 2, 3 objects. For each one of those, I need to make a connection and potentially get 1, 2, or 3 objects back from each one. For each object I get back, I need to execute this restarting method, or reboot method, or maybe a log off method, or whatever operation it is we're trying to complete. So I need to do this sort of enumerating through objects and working with objects individually twice. At the first level, I need to do something for each name that GetContent produces. Whatever GetWMIObject produces, I need to do something for each one of those as well. So we're really looking at some nested operations here. And the commandlet that's going to allow us to do it all is called for each object. Let's sort of outline what this is going to do. I'm going to get content, and I'm going to specify a file name that contains my computer names, the ones I want to connect to. Then I'm going to pipe those to for each object so that I can do something for each one of them in turn. I'm going to specify a script block that tells it what I want to do for each one. For each computer name, I want to connect to WMI. So I'm going to use the getWMIObject, or GWMI commandlet. I'm going to retrieve a particular class, and I want to connect to a remote computer using the -computername parameter. The computer I want to connect to is in $_, which represents the current pipeline object. So if GetContent from this file name is producing 3 objects, and that's what goes into the pipeline, then for each object is getting 3 objects, and this script block will execute 3 times. Each time it executes, one of those 3 pipeline objects will be placed into $_. That will allow me to connect to each computer in turn. So let's take a look at that in the shell itself. Get content from computers.txt, pipe to for each object. And then in the curly braces, I'm going to put my script block. For each name, I want to run getWMIObject for the Win32 operating system class, and I want to do it from the computer that's in the current pipeline object. So each object that comes out of this file, each name in other words, will be piped in. This script block will run 1 time for each object that comes in. Every time it runs, one of the pipeline objects will be placed into $_, and so that's how I'll give a different computer name each time. If I hit enter, I can see that it does run all 4 times, and it retrieves the 4 WMI objects. Okay, now I need to do something with each one of those WMI objects. So for each WMI object I get back, and it's possible that I can get more than one, so I'm going to erase that curly brace, give myself a little room, just write it down here. I'm going to pipe those WMI objects to another instance of for each object. This is nested. So I'm going to put a pipe and then another for each object. And in its curly braces, I'm going to take $_, which at this point represents a WMI object, not a computer name. And I'll explain that in just a sec. I'm going to take $_ and execute the, I believe the method is reboot, but we'll look it up in the documentation to make sure. I'm going to execute whatever method it is that I want to do, reboot. So here's what happens. GetContent runs first. Let's say GetContent produces 3 objects that go into the pipeline. Those 3 objects go into for each object. So this outer script block is going to run 3 times. Whatever object was piped into for each object is what goes into $_. this for each object is getting computer names. So this $underbar has computer names. The command getWMyObject is producing WMyObjects. Those WMyObjects are being piped to another instance of for each object. This for each object is getting WMyObjects piped in. And so those WMyObjects are what go into this $underbar. And those WMyObjects have a reboot method, and that's what's executed. Here's what it looks like in the shell. We'll recall that same command. And this time I'm going to include a pipe to for each object and another set of curly braces. Inside this curly brace, I'm going to run $underbar, which represents a WMyObject, reboot. Now we should check the documentation to make sure we're doing the right thing there. I'm going to go to my favorite search engine, search for that WMI class, Win32 operating system. Take a look at the documentation page on Microsoft's MSDN library website, and the methods it supports should be listed just under all these properties. And there is a method called reboot. Let's click and see how to use it. It's just reboot all by itself. It has no parameters, so that's all I need to specify. So this command will read a bunch of computer names out of a file, connect to each one of those computers via WMI, and retrieve the Win32 operating system class. For each Win32 operating system class, I'll execute the reboot method. Now, what can be a little confusing sometimes is that for each object actually has an alias that is just a %. So when you're looking at this in someone's example, maybe in a book or on a website, it can be a little bit difficult to sort of parse that in your mind. But just understand that that's exactly what it's doing. This just means for each object. Let's take a look at a second example. This time I want to go back to Google and look up the documentation on the Win32 service class. So we'll click over to that documentation page, and I want to look at the different methods that are available. I've got one called change. Let's take a look at this. Well, this accepts a lot of parameters. The first one is the display name, second one is the path name, service type, error control, start mode, desktop interact, start name, and start password. This is the password that the service uses to log on. This is the first, second, third, fourth, fifth, sixth, seventh, eighth parameter. So let's see how we can use that in Windows PowerShell. Let's go ahead and get all those computer names again. Get content, C, computers.txt. We're going to pipe that to for each object. What we're going to do with each one of those is get WMyObject, the Win32 service class, from the computer name that was piped in, but we're only going to get the one where the name equals MS SQL Server, Microsoft SQL Server. For each instance we get back, we're going to execute the instance's change method. And we're going to leave the first parameter blank, the second one, the third one, the fourth one, the fifth one, the sixth one, and the seventh one, and we're going to specify a new password. Now, unfortunately, these WMI methods don't have a what-if parameter, but this is an example of how you can read a bunch of computer names out of a file, connect to each one of those computers via WMI to retrieve a particular service having this criteria, and for each one of those services you actually get back, change the password it uses to log on. That's definitely a useful administrative task and something that you may have to perform from time to time as regular maintenance. In this nugget, we looked at two different ways of working with object collections. We started by looking at what object collections are. Basically just a bunch of objects that we can either work with as a group or that we can break apart so that the individual objects can be manipulated as individuals. We looked at some examples that use the for each object commandlet and Windows management instrumentation, We looked at one that would restart a group of computers, and we looked at another that would reconfigure a group of services on different remote computers. I hope this has been informative for you, and I'd like to thank you for viewing.